Okay, moving on to Tribal Data Toolbox Exercise 5. We're going to import metadata now. So looking at the exercise description, it tells us to follow the Meteorological Monitoring Data SOP. So we pull that up, and that's in our help documents. And looking through it, you can see it's fairly short because for the first steps, it's just the same as importing any other data. So you would click the import raw data file from sampler and then go through all the same import processes as we just did for ozone data. So it tells us to look at the SOP for continuous gas and PM data for steps A through J. So we do that. And we can see that we're going to follow all the same steps through mapping the headers onto the field names and all the way through the table verification, and those first steps are the same. So let's look back at the exercise description, and it says locate the meteorological text file for this exercise. It's been downloaded from a Met station at Site 1 for the same sampling time as the ozone data, but from the Met station data logger, the sampling times are start times. So we don't have to press that the end time to start time correction button, because the times in each row of this file here are actually the start times. So looking at that file, it's pulled up here, and you can see that it definitely looks different already. First of all, it just starts right in with the data. There's no header row. Then doesn't look like there's date really. We will learn that this column here is serial date, which some data loggers record every day starting at January 1 as 1 and then going on through the year through 365. So the tool, since we've seen this, the toolbox will accommodate this kind of configuration. And then the other thing to notice is that the times, 800, 900, they don't have colons. So we've got to make sure that we notice that. Looking at, since this is the same steps as getting a toolbox ready file, let's look at that checklist. Remember, it has to be a comma delimited text file. Looking at this file, well, it's a text file, and every new record, which will be in a new column, is separated by a comma, so that's good. Then we have to put the headers in. We know we haven't done that. Data does begin in row 2. No blank rows. We've scrolled through and seen that there aren't any blank rows. Contains complete dates in a common date format or serial date format, so we're okay there, and times, with each time in a new row. And yes, it goes from 800, 900, every row is a new hour, so that's good. So just checking those other checklist items. Contains a known and logged in your database logbook number of records. So let's look at that. And we see the status bar is checked. So that means when we put our cursor anywhere in here, including in the last row, way down here, it tells us we're in line 336. So that's good, because it means that we've got one header row, and so we write this down in our database logbook, and then we can check that off in the SOP for Toolbox Ready file. So one of the things that we also need to check is that if there's concentration or parameter data, not dates or times, has at least one digit after the decimal in the first row of data. So this is really important for precipitation, especially in the west, where we may get 0.01 inches of precipitation, and we want to make sure that we don't lose that information. When access and Excel imports data. If it sees just an integer in the top row, it's going to assume everything after that is also an integer, which means that it would either be 0 or 1. And we know that it actually rained a little bit in August, and we have something down here that's probably 0.5, and we want to make sure that that's not rounded. So one of the things we need to do in this file is first let's add the headers, because we know we're going to have to do that. So looking at the exercise, it tells us that these are the headers. So what I'm going to do is go into this text file. I'm going to put my cursor right at the very beginning, and I'm going to hit enter, and that opens up a new row here. And then I'm just going to copy these into the first row. And if your data logger was set up like this, you would probably have this text file just out on your desktop. And so you could copy, so I can either do Control-C or right-click the selection and say copy, go back into this, and then my cursor's there, so I can just right-click and say paste, and then it zooms me all the way over to the right where I see battery voltage. That's the last one that was in this. It's good, so it got that. And then I could pull this over to the left, and it started with output ID, and that was the first one. So each one of the headers is separated by a comma, and that's good. And now we need to see if in this second row there's an integer value, and there is, and it is for precipitation. So we want to just change this to 0.0. And now we're ready to save it as new import.txt in the Toolbox 2.1 folder. So I'm going to say save as, and I'm going to navigate to my C drive and my 2.1 folder, and now I'm just going to save it right on top of, replacing the old new import.txt. That old one that's still there is from our ozone data. I'm going to say nope, I want this one to be imported now. I'm going to say save. Do you want to replace that old one? Yes, I don't have to worry because I've got a backup copy. So now I'm ready to import it in the toolbox. Okay, so now looking at the SOP for metadata, you can see I'm still following the SOP for continuous and gaseous, because this goes all the way through the transfer of data into the verification table, and then only when I get to step K, update selected pollutants and units, and that's when you differentiate between metadata and pollutant data, do we go back to this SOP, the metadata SOP. So in my toolbox, I'm going to go to continuous and met monitoring and import raw data file from sampler, import text file. Yes, we have a comma delimited text file with field names. Import successful. Now let's look at it, and it's just how it looked in the text file. The first table in the pipeline of the toolbox, which is the table data import, just sucks in whatever you have in new import.txt. If you've got crazy headers or weird values that don't make any sense, it will take that entire table and it becomes the first step in the toolbox pipeline. So yep, that's our file. We could see that it's 336 rows of actual data. So we click the lower X and now continue to transfer to verification table, where we're going to put it into the middle table now, site 1, and we know it's from our MET station that we've already set up at site 1, and now we're going to set up the transfer. This is the scary part of Access. So these are the headers from the first table in the pipeline, and then we need to map these onto the headers of the verification table. Well, we know output ID, that's just the ID generated from our MetStation data logger, but we want these values, but we don't want battery voltage. That's not something we're going to store in the manipulated files. We'll keep the raw files. We want actually everything other than the first and last header in this case. Well, you can either pull them down individually, or, and I'm going to delete that one now, if you've got a lot here and you don't want to do that, you could select the first one and then put your cursor over the last one, hold down the shift key and then click, and that selects it, and then you could drag down all of them. And again, Access guesses, and it got year right, but that was the only one it could make sense of. So serial date, we know from reading the help file that the toolbox headers in the verification table call that Julian date. That's another date, or another term for Julian date. We know that we have to tell Access that these are hours because it does not have a colon in the time. Again, remember, it's just 800, 900, so we have to tell Access hour here. And then wind speed, because it has the units, it couldn't guess, but we've got wind speed here, we tell it. And then precipitation. And then if you can't see the whole field name, you can put your cursor over the middle of two columns, just like in Excel, and when your cursor turns into this black right and left facing arrow, you can pull it over to the right. Percent relative humidity, we select relative humidity. Again, we can pull that over. Degrees Fahrenheit, temperature, and we know this is outdoor temperature, so ambient temperature outside. That looks correct. Now we save and we press the lower X, and now we can transfer. So we're transferring it into the middle table, the verification table, from the data import table. Click that. Yes, 336 rows, that's how many there are. Now let's look at it. Okay, it just pulled it over and didn't do too much else with it. Year, Julian date, etc. Click the lower X. Now we want to update site and sampler ID so the toolbox knows where this came from. Yes, 336. And now let's just look at dates and times, and we know these are start times, so this is fine. We don't need to make a correction. Click the lower X. We don't need to press this sampling end time to start time correction because these times in our text file are already start times. Now here we're not importing pollutant, we're importing metadata, so we're going to click continue to import and qualify metadata. And now this is the same sort of thing as we did for ozone, but these are all meteorological parameters. And now it would be the time when you go back to the metadata SOP, because now we're looking specifically at the different units and ranges for metadata. So we're in this SOP now for meteorological data operations. Going back into the toolbox, we know from the headers here that wind speed is in miles per hour, precipitation's in inches, and temperatures in Fahrenheit. And that's also in the exercise 5 description. So we'll select miles per hour as the units for wind speed. We have precipitation in inches, ambient temperature in Fahrenheit, and those others aren't in this file. And if you make a mistake and want to change things around, you can clear all selections here if you want to, but that's what we want. So we'll click Update Selected Met Units. Yes, we want that for every one of the 336 rows to have those units be in there so we know what we're talking about. And then this panel here is about the same as that middle panel for the gaseous import data, but we've got all these different possible parameters, and the toolbox is engineered so that the values that you don't have, that you're not importing here, are grayed out here. So you don't have to look at these other values that you didn't import into the verification table. So the toolbox looks at where you've put the columns and says, okay, she's put a column of data in relative humidity, wind speed, ambient temperature, and precipitation. So these are pre-programmed values, and they're just common sense. You can change them. So the relative humidity shouldn't ever be outside 0 to 100%. Let's just say that you knew it never, if it went over 95, that would be for sure an error. So you could change these. Now click Display Out of Range Data. It says there's not any relative humidity values outside the range specified. Okay, is there anything greater than 80% relative humidity? Oh yes, we've got 50. So this was a pretty humid time, maybe during a monsoon. We're not going to qualify that because that's probably correct. Wind speed obviously probably shouldn't be higher than 999 miles per hour. Let's just look quickly and see if there's anything outside that range. Whoa, there is. Clearly this was when a probe was not attached or something. So we're going to click the lower X, and yes, we definitely want to flag those. So let's qualify these data. And yes, we just want to add flags to 4 rows. Now, ambient temperature. Well, this is a pretty broad range between -40 and 120 degrees Fahrenheit. Let's see if there's anything outside that range. Whoa, there is. And these are just errors on the 11th, again at 6 o'clock in the morning. So something was happening then. We definitely want to flag those. And that should be 4 rows again. Yes, it looks like something was going on there. And then precipitation. It never should be outside this range. Let's look and see. There isn't any precipitation values outside the range specified. Let's just say we knew that there was something wrong with the precipitation bucket, and if it read greater than 0.5 inches that there was a problem with it. Just click to see if there's anything. Oh, there is one, 0.67 inches. Let's just say the way our system works, we know that was an error, so let's flag that one. Okay, just 1 row, yes. So now let's look at what we flagged. So let's display all out of range met data, and that pulls up all the different values that are outside of the range that is in those fields in this box. So what we're pulling up also is this range here from 0 to 80% of relative humidity. Let's say, let's put that back at 100%, and now display all out of range met data. This comes up with only the few that we flagged that we know were erroneous because it was an error code, or because our tipping bucket should never show greater than 0.5. In this case it was, wow, really rainy day. So we've got these rows, and you can see there's multiple flags here. Well, this row is flagged out of range for wind speed and out of range for air temperature because both of those parameters were out of range. And then this says out of range precipitation because that's that 0.67 inches of precipitation that we're just saying is an error in our system. So you could see there could be multiple flags that get into this qualifier column, even multiple flags of the same if you go through this process perhaps several times looking at the data, and that's fine. You want more flags rather than fewer so that you can find any data you were curious about. So the next step is similar to importing the ozone data, to look at information in your logbook, audit results, things that you've gotten that you may have handy, and you know there are certain dates and times that you want to use to flag the data. So let's just say on the 11th, we know there was a power outage at 5 o'clock in the morning, and it went to noon. And now let's look at, and we have to tell it for what parameter. Well, it was actually for all parameters because it was a power outage. But let's just look at ambient temp, and let's look at that data. You can see that includes some of our already flagged data. Because we show in our logbook the power didn't come back on till noon, we're going to go ahead and flag that data, because right now we've got those 4 rows flagged, but we're actually suspicious about the data before and after those 4 rows. So I'm going to get out of this query window, and I'm going to say flag this data. Okay, yes, 8 rows, and now let's look at it again. And you can see that it added this ZAT for miscellaneous flag for air temperature. So it added, and then it already had those flags for out of range wind speed and out of range air temperature for those 4 rows. So close the query window, and now continuing on, just like for the importing the ozone data, we have to transfer it from the verification table into the archive table. So let's look at it one more time. And this shows all the 336 rows of data. You could see it added the units, and it's got the reading ID, it's got the date and time, it interpreted correctly. So this data look really complete. So we're going to click the lower X, and we are going to transfer it from the verification table to the archive table. So we're going to click this button, and it's going to transfer 336 rows, yes, into the archive table for meteorological data. Now let's look at it and make sure it got in there. Inspect the data archive table. And this is the first time we've done this import. What happens in these archive tables is as you import data, it keeps getting appended on to the end of the archive table. So eventually you're going to end up with really big archive tables, but we have included compact and repair in the instructions, so you should be fine for years and years. So that looks good. We're going to click the lower X, and now we have to clear out the pipeline. So it's very important that we clear the data verification table, and all that means is it empties out that middle table. It empties it out but leaves the shell of the table ready for the next import. Yes, and now at the bottom, don't forget the last step. We are finished with the import process for now, so we're going to click the first one. If you had more data, so for example you had the same file and some of the columns were pollutant data and some were met data, you imported the met data, but now you want to import the other columns, you would click that one. Or if you are ready to do an import from a different text file, you could click that one. So we're going to click the first one, and it will delete that whole table, so the pipeline is empty and ready for the next import. So before I email the reports or the toolbox that's required for this exercise to my instructor, I'm going to make a backup copy. So I'm going to get out of this toolbox and I'm going to go into my version 2.1 folder on the C drive. I'm going to say copy. I'm going to go into my toolbox backups folder. I'm going to say paste, and then right away, because I do not want two files with the same name on my computer, I'm going to say rename. Right click the file I just copied and say rename, and then I'm going to say after exercise 5 my last name. So now we have a copy of the toolbox we just did. When we start exercise 6, we will once again go back to the trunk and work from that one, but we know we will be working with the most up-to-date copy of the toolbox we have on our computer. Okay, so now we are continuing with exercise 4, and we are actually ready to import this file of ozone data that we have saved in the Toolbox 2.1 folder on the C drive. So we're going to open up the toolbox that we've been working from, and this is what I call the trunk, or Delbert Altaha calls the workhorse toolbox. And it should be the only file on your computer with this name. All your other toolboxes should be named some sort of backup. So I have a folder here, Toolbox Backups, and after I did exercise 1, I copied my trunk toolbox into this folder and renamed it after exercise 1. And after exercise 2, I forgot. And after exercise 3, I copied it. That's the most recent exercise I've done. I copied it into my backup folder and then renamed it after exercise 3. So now I'm going to begin the exercise with my trunk toolbox, and I'm going to open it. And I have to put in the password. And we are ready to import data. So I'm going to click Continuous and Met Monitoring. We've already entered the quality control data, so now we're going to import the raw data file from the sampler. So I'm going to click this, and I'm going to tell it to import a text file. And it gives me this warning. This will only work if your file is comma delimited, it's a text file, and it has field names, which means headers in the first row. If this is true, click OK. OK. Import successful. OK. Now let's look at it. Inspect Data Import Table. I'll click this button, and it pulls up the data that we just imported into the first step in the pipeline of the toolbox. Remember, the toolbox has a data import pipeline consisting of 3 tables, and the toolbox just pulled that new import.txt file that we created into the first table, which is table data import. And as you can see, it pulled the data all in, beginning on the 8th of August at 9 o'clock in the morning. And here at the bottom, we've got the navigation row, and you can see that's in record 1 of 336 rows. So it tells you right here that all the rows were pulled in. So we can click the lower X after viewing this table and saying, great, that looks right. And now the next button, continue to transfer to verification table form. Okay, I'll click that. Now, one thing that we know we're doing, right? Click here for help file. We have our help file open. And just to make sure that we're in the right spot, we've done the new import.txt file creation. And now we're here, creation of table data import from the new import.txt file. I'm going to hold down the control key and click, and it takes me here. And I'm going to make sure that I carefully follow along with this SOP. So we are here, and we don't see this message, so we don't have to follow the directions in the red box, which is when you didn't clean out the pipeline. And we're here. We have inspected the table data import table to verify that it was successful. We've looked through the data, and the number of records are the same as the number of rows in the file that we pulled off of our sampler. So it says, if this looks reasonable and the number of records are the same, click the lower X. And remember, if you are in the toolbox and you by accident click this upper red X, that's fine. You've just exited the toolbox and have to reopen it and navigate to where you were. So the next step here is we have to tell it, okay, what sampler is this from? What pollutant is this? It's from, we know from the description of the exercise, which tells us that this is an ozone file. It's taken from Site 1, and the sampling times are end times. Now, one of the things that is something you need to determine for your analyzers and data loggers is whether these rows, if this is 9 o'clock, when it says 9 o'clock, does that mean this represents the data from 9 o'clock to 10 o'clock? Or does this mean this represents the data from 8 o'clock to 9 o'clock? In other words, when the time appears as a row, as the item in the row, is that time the beginning of that hour or the end of that hour? So we've based everything on AQS, and AQS wants the data that they see to be start times. So in our exercise, the exercise tells us that these are end times. So in other words, what this row represents is 50.9 parts per billion ozone was the average ozone concentration from 8 o'clock to 9 o'clock on the 8th. And the next row is the ozone concentration average was 62.6 parts per billion from 9 o'clock to 10 o'clock. So in order to get your data into AQS, you have to change these so that these represent start times. And of course, this can get extremely confusing, so it really is important to make a note in your database logbook of what you're doing. So we are going to tell that the toolbox that this is from Site 1, and we know it's from Instrument 1 because that's the instrument that we have set up now at Site 1. And we're going to click this button, Set Up Transfer to Data Verification. And when we click this, this is the scariest part of Access. And we've started with a really simple file that only has 3 columns. So making sure that we follow along in the SOP where we are now, we've updated the site ID and the sampler ID, and we've clicked this button E, Set Up Transfer to Data Verification. So we are here, step E, and we're going to follow very, very carefully the directions, and they show an example of what we're doing here. So this is called the Query Design Grid, and what this does is it maps the headers. So these are the headers, if you remember, in the first table in the pipeline, table data import, we've got 3 headers, date, time, and concentration. We need to map those into the middle table, the verification table in the toolbox. The toolbox doesn't know what these values are, so we need to tell it. The verification table, the middle table in the toolbox, already has headers, and it has every conceivable header you could ever want. But the toolbox doesn't know what column to put from the table data import into the verification table what column to put it into. So what we're going to do is we're going to tell it. So clicking on date here from the table data import, drag it down by holding down your mouse button, release it here, and the toolbox guesses. It says, okay, this is the field called date, and I'm taking it from table data import, and I'm putting it in the verification table, appending to what column? Well, the toolbox is smart enough to know that date is probably goes into the date column. If you click the drop-down box here, you can see that there's all sorts of different columns you could map into, and we will be doing that. So date is pretty easy. The toolbox guesses correctly. Time, click there, drag it down, and again, time is pretty easy. Because if we look at our new import.txt, you can see that our times really look like times. It's got a colon there. So whenever there's a colon, the toolbox guesses that must be time, and it will work pretty well. Some data loggers just say 0900 without a colon, and in that case you need to be really specific and tell the toolbox that it's hour. In this case, you have a colon in your times, so it's really clear that that's time. So the last field is probably one of the most important, which is concentration. We pull that down and release it here in the third column, and you can see nothing appeared here because the toolbox can't guess. Cons 1 ppb, it's not smart enough to notice that that's probably concentration. So we click in the drop down box and we scroll down to concentration and click that, and now what we're doing is we're mapping these headers into the middle table, which is the verification table of the toolbox, and telling it what these data are. So we have to make sure we save this by clicking on the disk icon, then get out of the query design grid by clicking on the lower X, and we clicked too much, so we're going to go back and we are going to import the raw data file from the sampler because we're just navigating back to find where we were. So we were here, so I need to tell it site 1, instrument 1 again. We set it up. Let's just click this to make sure that it's okay. Set up transfer and make sure that it's still saved. Okay, good, that's still saved. Now we're going to click F, transfer to data verification from the data import table. So what this button does is it moves our data down the pipeline from the first table to the verification table. And the verification table is very important. That's where we tell it what units it is, what pollutant it is, and we're able to start managing the data by even reviewing it. So I'm going to click this, transfer, and it says, okay, you're going to make a modification, yes, and then it tells us how many rows. Good, 336. And now let's look at it. So now inspecting the data verification table, the middle table, we see, okay, 8 o'clock, or excuse me, on the 8th, 9 o'clock, 50.9, 336 rows, good. I'm going to click the lower X. And again, my mouse must be too fast. So I'm going to go back to navigate where I was. And we were here inspecting the verification table, and we have to do now is update the site and sampler ID. So I'm going to highlight site 1, instrument 1, and I'm going to click H, and now it says you're going to change your table 336 rows, because in every single row we need to say this is from site 1, instrument 1. Click yes. And now let's look at the dates and times. So if we look at this August 8th, 9 o'clock, and we're looking at our data logger manual, and we realize that our configuration for our data logger is set so that these are end times. And once again, we need to set these to be start times, but we don't want to say this was the concentration because then we'd be off an hour. So let's let the toolbox do it. Navigating back to where we were, let's make sure that we carefully decide whether we're going to press the sampling end time to start time correction. Well, we know from the exercise description, hint, you will use the end time to start time correction button. Now for your data, you only need to do this for those data streams for which it does log the end time instead of the start time. And it could be on your system, you could reconfigure it to log the start time, and in that case you wouldn't press this button. So you need to figure that out for your equipment, but for the sake of this exercise we were told to, so we will press the sampling end time to start time correction button. And this is cautioning us, saying that, are you sure you really want to do this? Okay. And it will modify data in our table, and every single row of the 336 rows is going to be changed. Everything's going to be bumped 1 hour. So we're going to say yes. Okay, so now we're going to continue to import and qualify pollutant concentrations or metadata. And we know this is ozone, so we're going to click this. Now in this form, we tell the toolbox what this data is. Well, we know it's ozone, so we could click that, and the units are parts per billion, so we click K, and we can follow along in the help file, the SOP. We're in section K, update selected pollutant and units. So we're going to say yes, and once again it's going to update every single row, because in every single row now it's going to say pollutant is ozone and the units are parts per billion. So we're going to say yes. Now at any point in this work here, what we're doing in the verification table, we can see what the toolbox did by looking at the verification table. And the verification table can be accessed by clicking this button over here. So we just updated it and told it was from ozone and units of parts per billion. So let's look at it. And we could see, okay, it knows now that, oh, look at that. It changed the 8 o'clock. Now it started on the 8th at 8 o'clock, and that's 50.9. So now we know that the ozone concentration from 8 to 9 was 50.9 parts per billion, which is correct. And it's from ozone and parts per billion. Good. Going to click the lower X, which takes us back to this form. So following along here, we're in step K. Now we're going to move to the next step over here, L, and this is qualifying or flagging data based upon different pieces of information that we might have. Well, first of all, the toolbox is pre-programmed to be able to search for ranges. And for ozone, it automatically suggests a range of 5 parts per billion through 999. You can change these values, and these values are based upon the EPA's minimum detection limit values for the different pollutants. But that might be different for what you're monitoring for, or you could just change these to see the range of data that you have. If you leave these ranges here and say display data outside of this concentration range, what pops up, you could see there's only 2 rows, and those are clearly error values. So on the 17th at 7 and 8 o'clock in the morning, maybe somebody was doing something and something was disconnected, and this is the error values that are produced. So we're going to get out of this just query that just showed these 2 rows, which takes us back to this form. Just if you wanted to look at what different values could pop up, let's just say that we were curious to know if there were any values greater than 75, or if, for example, we knew that there shouldn't be any values greater than 75. We could change that and now display data, and you could see that there were some values outside 5 to 75. And let's click the lower X. If you wanted to flag them, and again, the flagging is totally fine. You want to over flag data here, because this is just letting you find this data in the future if you have any questions about it whatsoever. So I'm going to click qualify these monitoring data based on these out of range concentrations. I click this and it says this is fine, but it doesn't exclude it from AQS. Yes. 16 rows. So there were 16 rows that were not between 5 and 75. And now let's look at them. I'm going to display data outside of this concentration range, and you can see it added a qualifier of R. So R just means out of range. Click the lower X, and this next possible way of flagging data is consecutive measurement difference. And this is something that came up in reviewing data where the values were just jumping all over the place. And we've pre-programmed the toolbox with default values. One caution about this is that if you're importing a lot of data at once, it'll take the toolbox a long time to do this calculation. What this does is if, for example, one row changes by more than 15 parts per billion from the previous row, it'll add a flag, just making you notice, hey, you know, the concentration changed a lot here. You can change this value. We're going to leave it 15 just as an example, and we're going to tell the toolbox to flag those rows where the values changed by more than 15 parts per billion from 1 hour to the next. And again, this just flags it so that we can find it easily later. So we're going to click this button. And depending upon how much data you've got, it might take a little while. If you're importing months and months and months of data, this query might take an hour. So that's why it's good to import little chunks of data as you go. So we're going to say yes. And then 9 rows, so there were 9 hours where the values changed by more than 15 parts per billion. We're going to say yes. And now let's look at those rows. At any time, I can inspect what we're looking at by clicking this Inspect Data Verification table. And now you can see this value, high difference, HD15, was added here because it changed from 62 to 80. So that's more than 15. This row changed from 20 to almost 40. And you can see that in some rows, there's more than one flag. So in this case, when the probe was disconnected or whatever the problem was, and then it started reading fine again, obviously it changed by more than 15 parts per billion from 1 hour to the next, and it was this first hour was out of range. So as you add flags, they'll just be added on in this qualifier column, and you can even have multiple of the same flags, and that's totally fine. So we're going to get out of this table by closing the lower window. Then the next step down is looking at the most recent QC data. So when we are looking at the data that we're importing, if we've already entered the QC data, it will appear here from most recent to older. And what we see is if there were any qualifiers. If you were curious and wanted to see, well, what was that on the 8th? I remember there was a guy out and I was showing him something and something was wrong with the level 10 check. So if we want to look at that data, you can click this, and this will pull up the row that matches the QC form with all the data that we entered. So when we're entering that data in the QC form, you could see we've got the device display here. So the ozone, it was putting ozone-free air through the analyzer. However, the ozone analyzer said that there was 28 parts per billion of ozone. That produced this level 10 flag, but looking at our notes, we know that that was corrected in, let's just say, 2 hours. So we do want to flag the 2 hours around this check that we made. So I want to qualify a few hours. I'm looking back at my logbook, and I did another check that was good after, but I want to flag the 2 hours that I've got here. So I'm going to click this, and what this does is it just says, okay, you were out there, you've got something you want to flag, tell us the dates. And it will pull up in this file that you're looking at now, the first all the way to the last, letting you flag whatever you want to flag. So we're going to say the data were bad from 8 o'clock in the morning until 10 o'clock. And it says, do you want to do this? Yes. 3 rows, yes. And now if we wanted to look at that and what happened there, we could inspect the data verification table, and you can see the first 3 rows here. We've added this qualifier, and that's in addition to these other flags here that we've already added. But you could see that the names of the qualifiers shed a little meaning. So I'm going to click the lower X, and now we're going down. This is another place where you could qualify the data based upon dates and times. So let's say you had an external auditor coming, and he came, and so obviously for the few hours that the auditor was there, or maybe more than a few hours, you need to flag that data because it wasn't reading ambient ozone concentrations from the outside air. So this is another place where you could tell it, for example, if the auditor came on the 12th at 2 o'clock in the afternoon and left on the 12th at 4 o'clock in the afternoon, we could look at that data. Let's just say the concentration was really, really high because they were running known concentrations of ozone through there. And we're going to say, yes, let's qualify that. So we qualify that. We say yes, yes, 3 rows, yes. And now let's look at that, and you could see it added Q1 qualifier, and there's a list at the back of this SOP of what these different qualifiers mean. So now, following the red line, we're at step M, and this is when we take a final look at the verification table. We say, is this we've flagged this is the preliminary data import, but as much as we know about this data now, we have put it in the notes field for our QC checks. We've added these qualifiers. We are ready to put this data with any other data we've been accumulating in the archive table. So we've inspected it. Now we're going to put it into the data archive. And do you really want to do this? 336 rows? Yes. Let's look at it. Ta-da! There it is. Our first data that's in the table data archive, all the way through now to the last table in the toolbox pipeline. Click the lower X. We have to make sure we don't forget to clear out the pipeline. So we have to clear the data verification table because we've put it in the archive table. So we're going to say yes, and it will delete 336 rows from the verification table, so it's empty again the next time we want to import data. Say yes, and now we have to make sure we click one of these buttons at the bottom. So if we've imported all the data, which we have, we remember in this new import.txt, it's only ozone data. There isn't like other rows or other columns of data that we might want to import now. We are finished importing all that. So we're going to click this button. If in the same text file there were other columns of, for example, NO2 data that we wanted to import, we could go back and import that now as NO2 data. or if we were ready right now to start importing from a different text file, we could click this button. We are ready to be finished with this exercise, so we're going to close forms and clear the data import table. We've imported all the data we want to right now. So we're going to click this, and it's going to say it's going to delete the table, the data import table. That's what we want it to do, because the next time we import data, we want it to import whatever data we have and not have this still stuck in the pipeline that we've already taken all the way through to the archive table. Click OK, and that takes us back to the main switchboard. And we are finished with exercise 4, except for, remember at this point, we need to, right now, we have done this work in this file here. That's our trunk or our workhorse. So I am going to make a backup copy of this before I'm finished with this exercise, so that when I begin exercise 5, I can go back always to my trunk, knowing that I've made a backup. So I'm going to say copy. I'm going to go into my toolbox backups, and I'm going to say paste, and then I'm going to immediately rename this because I don't want two files with the same name on my computer. I'm going to rename this after exercise 4 Ronca-Battista. Underscore. And now I've made a backup copy, and that's the end of exercise 4. Alright, we are working on exercise 4, and this is to import ozone data. So first it says, using the continuous gas and PM based data operations SOP for directions. So let's consult that, and we look at the first page of this. And it has these hyperlinks. We've already entered the quality control data, so we're ready for importing the raw data from sampler. I'm going to put my cursor over there, hold down the control, and then it turns into a little hand with an index finger, click, and it takes us to this section. So it first tells us about the colors of the buttons on the toolbox. And then it says, please note the following before you begin. The toolbox assumed that the data are collected on the hour. If this isn't the case, for example, if you have data collected every 15 minutes, we can work with that, but please contact us and we can talk to you about how to handle that. Data for each site and each analyzer must be in a separate file, and we will go over some examples of that. And be sure to have the time necessary to complete the full import. It's really common to get confused halfway through. After you've done this a few times, you'll be able to finish it fairly quickly. But the first time you do this, this will take you probably at least half an hour. So the first step is the new import file creation. And this step must be completed outside of the toolbox. And this is looking at your data and making sure it meets the criteria for importing it into the toolbox, which is basically just to be a text file. So it has to be a comma delimited text file and be formatted so that it's got headers, that the data begins in the second row, and that there aren't blank rows in the data. This is really common, and it's the same as if you're importing data into Excel. It has to have dates and times with each new time in a new row, and it says there is a SOP for a toolbox ready file for instructions in case we have to edit the file. So let's look at the file that we have as part of this exercise 4, and this is this new import file. This is data taken off of, I think, a Campbell Scientific Data Logger from an ozone analyzer. And let's look at the SOP for a toolbox ready file. So looking at my SOPs, first of all, you see in my C drive, Tribal Data Toolbox 2.1 folder, and then Help Documents, I have SOP for a Toolbox Ready file. So looking at that, let's see what it says. Well, it says that it must be a comma delimited text file as it told us before, and it says see the final page of this SOP for a checklist. So I'm going to scroll to the final page and look at that checklist and make sure that we meet the criteria. So let's look at this new import ozone data. It has to be comma delimited, have headers, data beginning in row 2, no blank rows, and each new time has to be in a new row. Let's look at this. Okay, so we've got the first row of headers and it's comma delimited, so Access or Excel will know when it sees this comma that that's going to be a new column. It's got date as the first column, time as the second column, and concentration. There's no comma there, so this is all considered to be the header of the third row. And then there's no comma, but it goes to a new line. So this is the first line of the data, and you could see that it starts on August 8th at 9 o'clock in the morning, and the ozone parts per billion concentration is 50.9. And one of the things that's really important is that you keep track of the number of rows that you import. Sometimes it really helps figure out what's going on. Well, how do you know how many rows are in this? If you go to, and this is opening by default in Notepad, if you go to View, and then make sure this status bar has a check next to it, and if it does have a check next to it, if you can see way down here on the right hand corner, it tells you where your cursor is. So right now my cursor is in line 2, column 2. And that is just a way of telling you how many rows you have in this text file. And if you go all the way to the bottom and put your cursor in the bottom row, it says that you're in line 337, and we know that there's one header row, so we've got 336 rows of data. The last date is the 22nd of August at 8 o'clock in the morning, and we're going to write that down in the database logbook. And going back to the first row, we've got the 8th of August at 9 o'clock in the morning for a total of 336 rows of data. So we're going to write that down in our database logbook and then take a look at this checklist again. So it's a comma delimited text file. We've got headers in the first row, data begins in the second row, no blank rows. It contains complete dates. Each time is in a new row. There isn't a 0 in the first row, which is really common for precipitation, especially out west. It contains a known and logged in my database logbook number of records, and I've got a backup copy saved. Now the final thing, it has to be saved in the Tribal Data Toolbox version 2.1 folder on the C drive. So what I need to do is go back to this, and it's ready to be saved. I didn't have to do any manipulation for this. I'm going to save as, and I need to tell it in my C drive, go to my Tribal Data Toolbox 2.1 folder, and I'm going to save it as new import, and then I've told it here that I want to save it as a text file. I can add .txt, save, and now let's check. So I go to my Tribal Data Toolbox folder on my C drive, and there it is, new import.txt. So that's it. Now I'm ready to open up the toolbox and import this ozone data.